Hello folks and welcome to Logic Gates. Today I'm going to take you through a few simple logic gates we're going to need to know for our course. So let's get started. The first one is an AND gate. This is called an AND gate, represented by a strangely elongated D symbol here. An AND gate says if A has power is 1 and B has power is 1, then C becomes 1. But if only A has power and B doesn't, or B has power and A doesn't, not happening. The system is not happy. Okay, so when both are 1, C is 1. If neither are 1 or only one has got a 1 or power, then the circuit will not work. Okay, so that is an AND gate. Let me try and write that down actually. AND gate. There we are, nice simple. You can admire my handwriting, I'm sure. Now, next is an OR gate. Now, an OR gate is a bit different to an AND gate because an OR gate still has A and B sitting here and here and still has C as the output. But for an OR gate, if both are 0 or both have got no charge, then C will have no charge. But if either A or B has a charge, or if both A or B have a charge, then C will have a charge. Okay, so if A is charged and B is charged, then C is charged. If A only is charged or B only is charged, then C is still charged. Nice and simple. Okay, the next one is a NOT gate. Now, NOT gates are slightly trickier and more fun to use. So if A has a charge, then B has no charge. And equally, if A has a no charge, then B has a charge. So whatever A is doing, B swaps it around and does the exact opposite, just to be awkward. How annoying is that, eh? So far, guys, we've covered AND gates, OR gates, and NOT gates. Now, the last one we're going to do today is called a XOR gate, spelled X-O-R, a XOR gate. Okay, and what a XOR gate says is if A is 1 or B is 1, then C is 1. And so far, just like an OR gate. But if both A and B are 1, then C is 0. So if there's a charge on A, a charge on B, then there will be no output from C because a XOR gate only accepts one input. Otherwise, it doesn't work. Not working today. Okay? Now, these guys are called transistors in electronics, and a modern Intel CPU has about 300 million of these on every single 2 inches square of silicon, which is quite a lot, I would say. Now, these can be built up into quite big circuits. Here's a simple one I made earlier. So here we've got an AND gate, a NOT gate, and an OR gate. So here I can say if A is 1 or B is 1, then the output here will be 1. And then so that's half the AND gate fulfilled. And then here, well, if C equals 1, then the output going through here is now 0. And an AND gate, you have to have 2 positive charges, 2 ones appearing. So here we need A or B to be positive, and we need C to be negative or no power. And at that point, this will output 1, the OR gate will output 1, and then the AND gate here will output, yep, you guessed it, 1 right here. Nice and easy. Okay, guys? So, a quick recap. Today, we have covered OR gates, AND gates, NOT gates, and XOR gates. If you have any questions, look on the VLE or ask me in class. Thanks for tuning in and talk to you again soon.